In this video we're looking at skew lines, and specifically we're going to look at finding the shortest horizontal distance between two skew lines. So skew lines first are two lines that are neither parallel nor intersecting. So they're not going to be parallel to each other and they're not going to intersect each other. Although in our question it appears as if they intersect each other, so they appear to cross each other, there's actually space between them. And the way to determine if they're not intersecting is if you take the point here where they appear to cross each other. If they intersect each other, that would be the same point where they intersect in plan, or they appear to intersect in plan. So this point and this point are not directly above and below each other, so these lines are not intersecting. That's just an important point to note. So what we have here are our two lines AB and CD. We've determined that they don't intersect each other, so what we're going to have to do in this question is find the shortest horizontal distance between them. That's going to require two auxiliaries, and first off what we're going to have to do is we're going to have to create a plane. So what we're going to do on one of these lines, we're going to create a plane with a horizontal line on it. The horizontal line will give us a true length, so we'll be able to look along that in a while. And then the third edge of our plane is going to be formed by a line that is parallel to the other one. The reason we do that is if we have a line and a plane with a line on it that's parallel to another one, we can find a view where both our lines are parallel to each other. So this is what we're going to do. First I'm going to find a line. So I'm going to use the line AB for my plane, and then on the other line I'm going to go parallel to that from the other line. So I'm going to draw a line parallel to CD from the end of B. So this line here is parallel to this one. On here I'm going to create a line now from A that's horizontal. And it's going to go over until it touches this point, and we can call that P. So it touches off point P. So what I've done is I've created a plane now that has a horizontal line in it and a line that is parallel to the line CD. What I'm going to do now is I'm going to find that same plane in plan. So I put point CD onto B, so I'm going to do the same thing here. I'm going to create a line that's parallel to CD from B, and I need to locate point B. So this one here, this line that I've drawn, is parallel to CD just like it was up in the elevation. I'm going to locate point P by projecting that down into the plan. That gives me point P there. So the horizontal line in elevation, the blue line, is now at true length in the plan. So using this technique, it's something that we will use in geologic geometry for finding the strike of something, and we'll be using it on a few other occasions as well. So what we're going to do now is we're going to look along the true length line that we've just found and draw an x1, y1 line that is perpendicular to it. So x1, y1. I need to locate each of the points, so for not just for this plane but for C and D also, out here. So A is going to be out along here somewhere, B is going to be on this line, D is out along this way, and C finally is also brought out. So we're going to take our heights from our elevation, so whatever height they were in the elevation. C was out 100. B had an altitude of 80. had an altitude of 55 and D had an altitude of 15. So drawing these two lines now, they appear parallel. So I found A, B, C, and this is point D down here. My lines appear parallel in this view. So once I found the strike line, or my true length line down here, that gives me a view where both lines appear parallel to each other. They're not actually parallel, but we've just turned them in such a way, we've changed our view that we have found them to be parallel to each other. The next part of this, so just quick recap there, the distances, the heights, the height for C, as this is an auxiliary elevation, is taken from this elevation. This for point B, the height from B to the x1, y1 line is the same as B to the xy line. So height back here. The next view that I need to do is I'm going to draw a second auxiliary. Now this second auxiliary, in our question we've been asked to find the shortest horizontal distance. So I'm going to take a view where I would be looking in horizontal to these planes. So looking in horizontal means I'm looking along the x1, y1 line. If I was looking at this way or that way, I would not be looking at a horizontal view of it. So now if I was to put this in here and draw a line, find my view up here, my xy line would be here, and if I drew a line up here, it would still be horizontal to it. So I'm going to look in parallel. I'm going to project my lines parallel to the x1, y1 line, and my x2, y2 line is going to be perpendicular to it. So x2, y2 is here, with my lines perpendicular to the x1, y1 line. So I'm going to project each of these points out now. So point D, A and B are all projected out. C also. And the distances that I'm going to be taking for this are found by going back and skipping a view. So I'm working in this view, I'm going to skip this view and measure from this xy1 line back. So if I'm to take my distance, let's say for D, I'm measuring from the x1, y1 line back to point D on the curve, or in my plan, and marking that up from the x2, y2 line. So this is D. Going to do the same thing for A, so from here, from my x1, y1 line, measuring back as far as A, and marking that from the x2, y2 line, so A is up here. This is B, so measuring the distance, again, same idea. And finally for C, from my xy1 up to C, and that's measured from the x2 line then up there also. This is B and C. So join A to B and C to D. And what we found here is, again, we found our lines. We found the lines A, B and C, D. But this time we're looking in a position where they appear to cross each other, and that's in a horizontal view. So this point up here now is going to give me, if I project that back, it's going to give me the shortest horizontal line that I can form between both of them. So I'm going to project where they cross back down. So everything up to this point now has been trying to find the question, to solve the question. Now I've solved it, I just need to draw my horizontal line. So I'm going to take this point and project it back down into the auxiliary elevation. And this line here now is the shortest horizontal line that I can mark into it. That is the shortest horizontal line. So I can see where they cross up here. I'm going to project this back down and draw in my line where it crosses the two. I still need to find it in the plan and the elevation, so to do that it's quite straightforward. I'm just going to project my lines back in the same way I projected them forward earlier on. So this line comes back until it touches the line CD, this one until it touches the line AB, and that is going to give me the line out here where the shortest horizontal line. And then in elevation, there's two ways I can project my line up along here, or I can mark the height of it up. So the height of this here, taking that height, and I can mark that up and then draw in my line, which will be between those two there. So that still lines up with my points above and below, but it's just a little bit more accurate. So up here then, that short line there, that is the shortest horizontal distance. So there we have it. That is the skew lines finding the shortest horizontal distance between two skew lines.